Dependence of nuclear force. This is the topic which have to be discussed today. So here I will tell you that what are the factors that affect the nuclear forces. As we know that nuclear forces are the short range and very strongest force. They exist only inside the nucleus. Outside the nucleus, they have no importance at all. So these nuclear forces are the strongest force of the nature, as this force holds all the nucleons together inside the nucleus. So now I will tell you the factors upon which this nuclear force depends. Now first factor is the spin of the nucleons. Spin of nucleons. The nucleons in the nucleus are not lying haphazardly, but they are lying in a manner just like the electrons outside the nucleus. So they follow, they are lying in the different energy states. So they have the spin, as well as they have also the angular momentum. So the spin of the nucleons may be parallel or the anti-parallel. When the spin are parallel spin, like this is now parallel spin, or like this, these are the parallel spin, then the nuclear force are strong. Is strong. If the spins are anti-parallel, spin of nucleons, that this is now like this one, this way, or this is now like this one. So if the nucleons have this kind of the spin, that they are anti-parallel, then this nuclear force is weak. This is why that sometimes we say that the nuclear forces are two types, the strong nuclear force and the weak nuclear force. So strong nuclear force, when we say this sentence, it means that the nucleons have the parallel spin. And when we say that the nuclear force is weak, it means the spin of the nucleons is anti-parallel. So these nuclear forces are spin dependent. Hence, nuclear force is spin dependent. Now the second term. The second factor is the distance between the nucleons. Now let R equal to distance between nucleons, and it must be clear to you that nucleons are nothing but the protons and the neutrons, which are the stable particle in the nucleus. If R is less than 0.8 Fm, Fm is Fermi, 1 Fm equal to 10 raised to the power minus 15 meter. This is the unit of to represent the radius or the diameter of the nucleus. If R is less than 0.8 Fm, then nuclear force is repulsive. Nuclear force is repulsive. If R is greater than 0.8 Fm, nuclear force is attractive. Nuclear force is attractive. If R is equal to 0.8 Fm, if R equal to 0.8 Fm, nuclear force is neither attractive nor repulsive. Is neither repulsive nor attractive. This tells you the nature of the nuclear force. This nuclear force, that may be the attractive or that may be the repulsive, depending upon the distance between the nucleons. So we can have this, we can show by graph. This we say the nuclear force F, and this we take R on this side, then the curve is like this one. Now this distance, this is now R naught. R naught is what? 0.8 Fm. So this is 0.8 Fm. So R naught. So this part shows the repulsive force, and this part shows you the attractive force. Attractive force. At distance 0.8 Fm, the potential energy of the nucleus is minimum. So this shows you the variation of the nuclear force with the distance between the nucleons, and it has been found that if this R is equal to 2.5 Fm, then this nuclear force vanishes. for R greater than 2.5 FM, the nuclear force vanishes. It means that we are not inside the nucleus, but we are outside the nucleus. In that case, this nuclear force has no importance at all. Now the third factor. Exchange particle. Now exchange particle is meson, and this meson is of three kinds. Three types of meson. This is now your pi 0, pi plus and pi minus. So these are also called the pi meson. So pi meson is of three types: the pi 0, pi plus and pi minus. This is according to the nature that the nucleons are the positive charge particle and the neutral also. For example, the proton has the positive charge, but the neutron have zero charge. So according to this meson particle plays an important role to have the nuclear force. So now what is there? That in case of PP force, PP means force between proton and proton. Now the proton is the positive charge particle. So now what we have, that this, like this one, this is now proton plus pi plus, that is now proton. So the reaction that may be like this one or in this way. So between proton and proton we have this pi plus meson particle. Neutron force between neutron and neutron. Neutron are the neutral particle. So this is now your n plus pi 0, then this n. So between between the neutral particles, the neutron and neutron, we have the pi 0 meson. Then this Pn or Np. Pn force. Now here we have this P plus, this is now your pi minus, then this is now your N. And we have this Np force, then this N plus pi minus, then this is now your P. So if we have this Pn force or Np force, means the force between proton neutron and neutron proton. These are the two different ones. So in that case we have this here, this pi minus, and here we have this pi plus. And here we have this between proton and proton, the pi plus particle, neutron pi 0 particle, proton neutron, this pi minus particle, neutron proton, pi plus particle. So these are the three factors upon which the nuclear force depends. So this is about the factors that that also affect So now there are three factors. First, the spin. Second, the distance between the nucleons. And third, the exchange particle. Though this nuclear force is not charge dependent, and also it equally exists between all the pairs of the nucleons. So this is about the nuclear force dependence. So thank you very much.